Hi there, welcome back to Nadz Academy. In this video, we'll dive deep into the heart of the software development models, from the classic waterfall to the agile wonderlands like Scrum and Kanban. We'll explore their strengths, weaknesses, and how they will help you navigate the exciting world of software development. So let's start. A software development model, which is also known as Software Development Lifecycle Model, is a structured framework used in the development of software products. It defines the processes, stages, and activities involved in creating software, offering a roadmap for teams to follow. These models vary in their approach, methodology, and workflow, catering to different project requirements, team dynamics, and organizational goals. Understanding these models is crucial for efficient project development management and successful software delivery. In this video, some important types of software development models are discussed in detail. Waterfall Model. Waterfall Model is a sequential and linear model with distinct phases like requirements definition, system and software design, implementation until testing, integration and system testing, and operation and maintenance. It is easy to understand, manageable, and suitable for large systems engineering projects where system is developed at several sites. However, it lacks flexibility and has limited scope for changes after initial stages. This image illustrates the sequential nature of waterfall model, with each stage completed one after another, falling downwards like a waterfall. This provides a clear and structured approach, but also highlights the potential rigidity and difficulty in making changes later in the process. Agile Model is iterative, and its flexible approach focuses on collaboration, adaptability, and customer feedback. Common methodologies include Scrum, Kanban, and extreme programming. It emphasizes more on customer satisfaction, accommodates changes easily, and promotes teamwork. However, it requires active customer involvement and may be challenging for large teams. Agile models represent a more flexible approach to software development, unlike the linear flow of the waterfall model. Here are two common agile models visualized: the Kanban board and the Scrum. Think of a Kanban board as a visual project management tool. Imagine a whiteboard with tasks divided into three columns: to do column, in progress column, and done column. In to do column, upcoming tasks are placed, waiting to be picked up. In progress column, tasks are placed which are currently being worked on. In done column, completed tasks are placed, signifying progress. Team members pull tasks from to-do column into in-progress column, one by one, limiting work in progress to avoid overburdening themselves. This visual structure promotes transparency, prioritization, and continuous improvement. A Scrum model focuses on short, iterative development cycle called sprints, typically lasting 1 to 2 weeks. Imagine a sprint as a small race where the team aims to complete a specific task within the set time frame. Here the Scrum team in action. Product owner sets the vision and priorities for the product. The Scrum Master facilitates the Scrum process and removes obstacles from the team. Development team, a set organized group responsible for completing the task during each sprint. First stakeholder plan the sprint keeping product backlog. Meanwhile, data of daily Scrum is being recorded in sprint backlog. Once the sprint is done, the increment, that is, the part of the project that has been completed, is reviewed as a sprint review. Then sprint retro is performed. In case, if any error or correction found, then it is refined and data is kept in product backlog. This image provides a glimpse into the dynamic and collaborative nature of agile models, where adaptation and continuous delivery take center stage. A spiral model combines the iterative nature of prototyping with the systematic aspects of waterfall model. It emphasizes risk analysis and gradual development. It allows for early risk identification, mitigation, and accommodates changes during the development process. However, it may involve higher costs due to risk analysis phases. Each phase of this spiral model is divided into four quadrants. In first quadrant, objective determination and identification of alternative solutions are performed. Requirements are gathered from the customer and the objectives are identified, elaborated and analyzed at the start of every phase. Then alternative solutions possible for the phase are proposed in this quadrant. In the second quadrant, identification and resolution of the risk is performed. During the second quadrant, all possible solutions are evaluated to select the best possible solution. Then the risks associated with the solution are identified and the risks are resolved using the best possible strategy. At the end of this quadrant, the prototype is built for the best possible solution. In third quadrant, development of the next version of the product is performed. In this quadrant, the identified features are developed and verified through testing. At the end of the third quadrant, the next version of the software is available. In fourth quadrant, review and plan for the next phase is performed. The customer evaluates the so far developed version of the software. In the end, planning for the next phase is started. This image effectively captures the iterative and risk-managed nature of the spiral model, making it a compelling choice for complex projects where requirements might evolve or uncertainties prevail. An extension of a waterfall model is a V model, which stands for Verification and Validation Model. It focuses on validation and verification at each stage of software development, emphasizes on testing and validation process, reducing risks which are associated with damaged software. Its rigid structure limits the flexibility of allowing changes during any development stage. As you can see, the left side of the V depicts the development phases, starting with requirements analysis and processing through system and module design, coding, and integration testing. Each phase on the left side has a corresponding testing counterpart on the right side, starting with unit testing and mirroring the development phases until reaching system and acceptance testing. This V-shaped structure emphasizes that close collaboration and parallel nature of development and testing activities. This model is the integration of the software development and IT operations to enhance collaboration and communication between development, operations, and quality assurance teams. It streamlines development and deployment, promotes continuous integration and delivery. However, it requires culture and organization shifts, along with an initial complexity in setting up the process. A development operation lifecycle entails 6 repetitive phases representing the capabilities, processes, and techniques crucial for development. The loop has left and right sides, which are different operational capabilities, processes, and tools. Each phase encounters separate but constant collaboration of teams and communication to ensure velocity, alignment, and quality of the processes are maintained. The life cycles are planning, building, integrating, and deploying, monitoring, operating, and responding through feedback passage. Before development, each team should be well equipped with open tools and rules at every development stage. The process results in the fast development of superior quality software, which is reliable. The fact that these stages are iterative, they make bug recognition easy and quicker. Remember, each software development model has its strengths and weaknesses. The choice of model depends on project requirements, team dynamics, and client preferences, and the nature of the software being developed. The flexible approach, combining aspects of different models, often proves beneficial in today's dynamic software landscape. We hope you like this video. Those who are interested in knowing about software engineering, they can watch our episode on exploring fundamentals of software engineering from the link given in the video description. Don't forget to like, share and subscribe for more content. If you want us to cover any specific topic, then let us know by dropping us a comment below. Thank you for watching.